Hello, can I come in?
Sure, come on in.
Hello, Professor K. How are you?
Fine, very good.
So recently, NASA's Perseverance landed on Mars. What is the mission for going to Mars?
Well, there are several new firsts with regards to the Perseverance spacecraft. First of all, it is the first spacecraft to have a helicopter. We have never placed a helicopter on another celestial body in the universe. So this is a first, and it means that in the future we may have more helicopters roaming over the surface of Mars. That's a first. Second, the Perseverance is going to undergo rock retrieval. It's going to gather rocks that look interesting and hold on to them until the next rover comes in several more years, picks up these rocks, and then takes them back to the planet Earth. So rock retrieval is a new feature of this mission. And we should also realize that Mars rocks are already on the planet Earth. We know that meteorites, when we analyze them, some of them have the exact mineral and atmospheric content of rocks on Mars. Therefore, we know with 100% certainty that these rocks came from Mars. So a meteor of some sort hit Mars, blasted rocks into outer space where they drifted for millions of years and then landed on the planet Earth. But with the Perseverance rover, we want to actually get rocks at will, pick them off the ground, they look interesting, and then we're going to bring them back to Earth. And third, this mission is in some sense a preparation for the manned exploration of Mars. The rock retrieval process is very similar to an astronaut retrieval process. So when we put astronauts on Mars, we're going to retrieve them in much the same way. We'll send a capsule down to Mars, pick up the astronauts, put them in orbit around Mars, and then from there they would blast off back to the planet Earth. And so rock retrieval in some sense is a mini rehearsal for astronaut retrieval.
So you said that they're gonna launch a helicopter. On Mars, the gravity and the atmosphere is different. So what effects are they going to do to the helicopters?
Yeah, it's very difficult to have a helicopter on Mars because the atmospheric pressure is only 1% that of the atmospheric pressure on the planet Earth. So the lift you get is about 1% of the lift you would get with a helicopter on Earth. And second of all, the atmosphere is mainly carbon dioxide, but that doesn't affect the helicopter so much. But it does mean that there's very little oxygen at all in the atmosphere of Mars. It's mainly carbon dioxide. But if this mission proves successful, then it means in the future we might have teams of drones roaming over the surface of Mars, giving us continuous monitoring of interesting geologic sites on the red planet. So this could be just the beginning of one day a fleet of helicopters and drones roaming over the surface of Mars continually.
For the rock retrieving process, is there any chance that they're going to find any life form or fossils of ancient life forms?
Probably not. However, there's always a possibility that they may pick up some kind of fossilized evidence or maybe evidence of microbial life. You see, Mars once was tropical. Mars cooled down before the Earth. Earth and Mars were both formed about 4.6 billion years ago. And for about a billion years, Mars and Earth were molten. But Mars cooled down first. While the Earth was still molten, Mars was tropical. And it had large bodies of water. We know this because we can see riverbeds, we can see channels, we can see the markings of water flowing freely on the surface of Mars. So we think that liquid water existed on Mars perhaps for hundreds of millions of years. And in that time, there may have been enough time to get microbial life off the ground. But this, of course, is still an unknown.
When in the future, when people go to the Mars, is it possible to place water on Mars?
It might be difficult. What's a more feasible idea is to melt the polar ice caps. Mars has plenty of water. The water is either underground in the permafrost, solid ice underground, or at the polar ice caps. So one possibility is to put solar satellites around Mars that beam down sunlight onto the polar ice caps, melting the polar ice caps so that liquid water flows freely on the surface of Mars after an absence of almost 3 billion years. So that's a prospect that may take, many decades, maybe centuries before we can realize it. But that would be the first step toward terraforming Mars, that is, melting the polar ice caps.
Many science fiction stories says that we may need to escape Earth and go to a planet. Is that even going to happen? And if it does, when will it be?
Well, we don't know the answer, but remember the dinosaurs did not have a space program, and that's why they're not here today. There are no dinosaurs around except maybe birds because of the fact that they didn't have any technology. Now, we do have technology, and it's inevitable that we have to leave the Earth at some point. In 5 billion years or so, the sun is going to eat up the Earth. The Bible, for example, says, from dust to dust, ashes to ashes. Physicists say, from stardust we came, and stardust we will return. So in about 5 billion years, the sun will expand so rapidly that the sky will be on fire. The oceans will boil, the mountains will melt, the sky will be on fire, and we will go back into the sun as the sun becomes a red giant star. So before then, we should have a space program that would take us to another star system. Now, in the English language, perhaps one of the most pessimistic paragraphs was written by a famous British mathematician, Bertrand Russell. Bertrand Russell, in a very depressing paragraph, said that for all the tears that we shed struggling on the planet Earth, trying to make a living, it's all for nothing. It's all for nothing because we're all doomed. The laws of physics say that when the sun dies, the Earth must necessarily die. So why are we struggling? Why are we doing anything, knowing that ultimately it's for nothing? But you see, that was back in the 1930s. Now we have rocket ships. Now we realize that the solution to that problem is, when the time comes, either we adapt or we leave the Earth.
Thank you very much, Professor K.
Well, it's been my pleasure.